Hi everyone. Have you ever thought about what this little angle here in the wings is for? Why they're always slightly bent upwards on any model airplane you'll find? At least most model airplanes. That's called dihedral. And more specifically, how much should that angle be? If you're making your own model airplane, how much dihedral do you actually want to use? So today we're going to try and find out the answer to that question. Okay, so let's say that this is just your standard airplane as viewed from the front. We just want to know how exactly does this make the airplane fly in a straighter line or contribute to overall stability. The way it adds to stability in theory is that if there was a wind gust that were to say disbalance the airplane, so it pushed against, it was from this direction I mean, and it hit the side of the airplane on this wing, it would cause a slip to the side here, like so, right? But when it slips, the oncoming airflow from this side would hit this surface of the wing, and that would cause a restoring force to bring the whole aircraft back to equilibrium. Having this creates a much larger surface area for the restoring airflow to hit the wing and bring the airplane back to an even keel. Theoretically, the larger the angle, the more stable it should be because of the larger incoming airflow. Right? Is that actually how it works? Adding dihedral like this reduces the total lift of the wing because some part of the lift of the wing is wasted because the wing is now actually lifting more like that on either side. So some of that lift is being wasted as it's going to the horizontal component instead of the vertical. For something like a Balsa glider, if there's too much, the lift of the wing is going to be wasted. Too little, the whole airplane is going to be unstable. We'll try to find that balance through experimentation. Okay, so this is the glider just in its standard configuration. So what if we were to increase that angle and see how it affects the whole overall stability? Okay, this is going to be flight number 1 with no modified dihedral. Okay, try that a second time. To try to do some loop-de-loops and a bit more acrobatic moves here. So all I'm going to do now is just change the dihedral a bit by cutting apart and re-gluing this wing. Okay, I'm just going to add a piece of baking paper to make sure the wood doesn't stick to the table. Apply a light bit of glue here. And there we go. Okay, so doing a bit of trigonometry, you find that this angle here right now is about 15 degrees. Okay, take 2, trial 2 with 15 degrees dihedral. With 15 degrees dihedral, there's not too much difference. It's not at the optimum point yet. Okay, so we're going to try that again. This time we'll put a much more significant dihedral and see how it goes. Watch how simple this is. Okay, so trial number 3 with much larger dihedral this time. I measured it to be about 23 degrees this time. Okay, yeah. Oh yeah. So we do have a little bit of wind right now. I'll wait for that to stop. Okay. Oh yeah. Wow. Fantastic. These are much better results than I was expecting. Wow. 23 degrees is definitely a good dihedral to work with. Okay, so those were surprisingly good results. So maybe just for kicks, we'll try and increase it a little bit more. Okay, 30 degrees. So it is very stable, but there is kind of a loss of lift and seam. Any other angle beyond 30 degrees just wasn't very promising. It's really interesting to see how, with the changes in dihedral, there was a change in the pitching of the aircraft. The motion with little to no dihedral was very unsteady vertically. You can see that they pitch upwards much more significantly than the ones with dihedral. I'm not really sure how to explain that. Maybe increasing the dihedral changes the center of lift of the aircraft, which results in more nose heaviness, which causes less pitching upwards. So if you're building a model aircraft, maybe hand building it, looks like probably around 25 to 30 degrees dihedral, anywhere between there, would be your optimal. That's only for a small glider like this. Anything bigger, generally the bigger your glider is, the more stable it is, just because it has more surface area. But for something this size, probably 30 degrees is a safe bet to get a very stable, well-flying aircraft. Thank you for watching. If you enjoyed the video, please like and subscribe. It'll help support my channel. I'll know that you actually enjoy the content and want to see more. Till next time.